Hi, I'm from Northern Ireland, and we have a slightly different way of approaching highly stressful technological problems. But hopefully, you'll find this relaxing, informative, engaging as well. I fully expect lots of difficult questions. I fully expect not to be able to answer all of them. So feel free to stop me as we go through. Um, just a show of hands. Who here has worked on an enterprise platform that has made it into production? Excellent. So half of the way through, you'll all be putting your hands up to correct me. Wonderful. Um, who here believes that testing is an important part of that process? Awesome. That'll save on holy wars later on. Yeah. So we're going to talk a little bit about what it takes to actually build an enterprise platform in this day and age. And we're going to base our platform upon Riak because it's a piece of technology that is 100% Erlang the whole way through. And it uses a lot of the best features of Erlang as well. One of the key challenges is to make sure that we don't cover everything under the sun. So we're going to have to be very, very focused. This is Basho Man. I didn't draw him. My artistic talents do not extend that far, but he's very, very nice. So our focus is going to be primarily on design. How do we design an enterprise architecture, which is based and built upon Erlang technology? We'll explain why we picked Erlang a little bit later as well. We'll look at some of the challenges involved with building something, testing it, making sure it releases properly, making sure it scales, making sure it's actually useful as well. We'll also take a look at some of the key decisions that you need to make in terms of things like strong eventual consistency, scaling factors, availability, persistence, those sorts of things as well. And finally, we'll talk about production, because most of you, like me, have had that dreaded feeling of a deadline, followed by a live release, followed by lots of people wondering exactly how successful it is, followed by taking responsibility for maintaining the thing. And the whole point of, going through testing, going through the process of making these decisions is so that when you finally get out at the other side and you've built your device, you do not have to worry so much at the other end. So, let's get going. Let's talk about the facts of life for architects. We're going to talk about one of the hottest topics around at the moment, big data. The reason we're going to talk about big data is because it's particularly relevant for the kind of applications that we're going to use in a highly performant, highly scalable, very resilient platform. The key thing about big data is that it is huge. And we'll talk a little bit about why that is as well. We'll touch on Erlang. We'll touch on why real-time analysis and real-time responses and analytics are crucial for any kind of enterprise platform at the moment. And we'll talk about the key pieces of technology that we're going to deal with as well. This is a good point actually to ask. How many people have worked with Riak? Awesome, about half the room. How many have worked with or played around with Redis? About a third of the room. And what about Apache Spark? Okay, that would be me. Apache Spark, for those that don't know, is an AI machine learning library which is maintained by Apache, and it makes scaling up analysis and generally producing intelligent results out of very large data sets incredibly easy. It's quite good. I heartily encourage you to try it out. We'll also do a little bit of a system overview of what the architecture is going to look like, what key bits need to be built, what stuff comes out of the box. And finally, we'll get to the painful bit about testing, staging, and releasing the final thing. Any questions? Good, awesome. All right. So, why big data? When you get data, typically it doesn't come in any particular form that's immediately useful. You're going to have to sort it, analyze it, classify it, make a decision based upon it. When you go through that process, it becomes information. When you actually find that information is useful constantly, then it kind of gets promoted up to the level of knowledge. But being able to take raw data in and being able to process it into information quickly and make decisions on the fly is incredibly important. And that's one of the things that we're going to aim for our enterprise platform. There's no point in building it if you can't deal with vast amounts of data concurrently and reliably. The frank matter is that most organizations nowadays deal with two very, very important types of data. There's data which is effectively brochureware, stuff that you push out on webs or mobile applications that just tell people what something is. The other bit of data is what everyone really cares about. It's where money gets transferred, goods get transferred, services get transferred, people complain, things need to be audited, et cetera, et cetera, et cetera. And there are different enterprise requirements for both of those bits of data. And you have to create an application platform and an enterprise platform that caters to both. Okay? And as we grow in the volume of data, the variety of data, the fact of the matter is you're going to have to become much, much better at dealing with it. Ever narrower segmentation. It's not enough to know that your customer is a person. It's a good idea to know that they're in your market. It's even better to know who they are. And it's even better to know why they want that particular service that you want. And that involves work and effort on your part. So big data is perfect for that. We're also going to talk about some of the sophisticated analytics that you can use within Spark to be able to improve your decision making. And you can also use big data to develop and refine your products as well. So it's not just a matter of selling people the stuff that you already have. Analyzing your data in real time allows you to analyze the behavior of markets in real time. And that allows you to be able to generate new types of products which are specifically fitted to your individual customers and clients. And you'll notice that that's a trend that's increasing more and more. Pardon me. This is why I brought some tea with me. This is the evolution of NoSQL over the past sort of 5-6 years. If you guys think back to when you started your careers, you were typically dealing with much simpler forms of data. One of the biggest challenges that we've all had to face is how to connect to a database, how to pull back stuff, and how to make it display or dance in the way that we want. And when we started off, the data that we got was typically point solutions. So you pull it back, tells you something, yes or no, you make your decision. Later, as you had different decisions to make about the data, and things became much, much more complex, you ended up with the notion, say, of a person, or a class of people, or a class of products with different variations, et cetera, et cetera, et cetera. So you had multiple models of the same underlying bit of data. And now, if you try and look at even the same type of thing that you were looking at before, let's say a person, you could have gigantic gigabytes, multiple streams of information which are relevant and connected to that person. You've got location data, you've got data on who they are, how much they own, who they're connected to, social data, things like influence, et cetera, et cetera. And that's just for people. You can apply that kind of thinking to pretty much any type of data that you have to deal with. And as such, the individual items of data become more complex and become harder to process. And the relationship between them become harder to process in a simple, straightforward manner that used to be the case for, say, point solutions. Does that make sense? Okay, cool. So why Erlang? The biggest reason is that it's very, very good at utilizing multi-core systems, that it grows very well, it fails fast, it fails elegantly, and typically when it does fail, you don't have an impact at the application level. It can stay in continuous operation for many, many, many years. It's very reliable. It's responsive to users. It's upgradable. It handles a large, large number of concurrent connections. One of the key problems that I had, and that a lot of people had, especially with database technology and building enterprise platforms, was that you often had, let's say, a very large cluster database with a load balancer that could only take a few connections at a time. And then as things got better and better and better, you got better systems and you had to do things like thread pooling, et cetera, et cetera, et cetera. With Erlang, if you have a piece of technology like Riak, and you have, say, 5 nodes inside a cluster, each of those nodes can accept hundreds, if not thousands, of connections at the same time and serve them back out at the same time. Erlang is awesome for that because the overhead for processes is incredibly low, and because there's a focus on making it reliable. Any questions? Cool, okay. Now, we talked about the models that we have to deal with our enterprise platform becoming more and more complex. We also need to take into account the fact that the volumes of the data become larger and larger and larger. Add to that the fact that a lot of this technology is now available in open source to not just your friends and your family, but also to commercial partners that are developing actively with it and trying to get the best that they can from it. And you'll see that the data volumes that you have to process are getting larger and larger and larger. And at the same time, your ability to make competitive decisions that lead to an advantageous position for yourself is getting smaller and smaller and smaller. For that reason, you need to be able to relay your results back out from your data set, and that's why we're talking about Redis. And you also need to be able to analyze those systems and scale up your analytics process alongside the scaling up of your data store as well. And that's why we're talking about Spark. Does that make sense? Cool. Okay. So, about half of you already know what Riak is, and the way we're going to build up our stack is to have Riak as the data layer. There are a few very good reasons for this. It's very simple to operate. Typically, you only need one line of code in order to be able to set up a cluster, add nodes or move nodes. You don't have a lot of the master-slave relationships that people typically worry about when you're building an enterprise environment. How many people here have worked with MySQL? Wow, that's everybody. How many of you have had to build master-slave relationships inside a MySQL environment? Okay, that's a lot fewer. How many of you found that process successful? Yeah, everyone's doing that. That's quite good. Asset compliance is very, very important. People bang on about it all the time, right? The problem with asset compliance is it only applies to one database. It doesn't apply to the whole cluster. You still have to deal with all the problems. Riak is very good in that. You don't have a master, you don't have a slave, simply add the nodes as you go along to deal with the capacity that you need and the demand that grows. And then you just let the database do the work of replication, making sure all the data is consistent, and of even things like read, repair, etc. So you can lose nodes, bring them back online, add more, etc., etc. And that's the beauty of it being simple to operate. Having worked a decade and a half building these things day in, day out, I can tell you there's a reason why I put simple to operate up at the very, very top. It's very important when you build your database layer, if you are going to use it as a foundation, that you're able to build it and then you're able to move on. Okay? Hands up if you disagree with me, because this is a point that I'm willing to talk about. Great, fantastic. Highly available. We talked about it being able to use multiple concurrent connections from each particular node. We talked about being able to add more nodes as you go along. The fact is that if you have more and more and more data, you want to be able to process it in parallel, and you want to be able to serve it out in parallel as well. One of the nice things about a data layer, be it Riak or anything else, that does provide high availability is that you have a lot of problems in that category which just simply go away. If you put a load balancer in front of, say, something like Riak that does this, then you do not have to worry. Quite simply, you can simply scale up, and as long as you have enough network bandwidth to be able to cope with it, your database will be able to provide responses. It's highly fault tolerant. Because of the way in which Riak works, and it relies on a lot of the core strengths of Erlang, if things fail, there are always backup processes and backup processes. There's things like read repair, automatic entropy optimization, where each cluster optimizes where the data lives and makes sure that everything is synced up. If a node goes down and there are copies of data on that node, and you have a requirement for availability, say 3 times across the network, the rest of the nodes will be aware of that, and we'll take that data from elsewhere, copy it out, and make sure that your database has those 3 available alongside the existing one that you originally looked for. That's quite important as well. It means that not only do you have the ability to do away with master-slave relationships, you also have the ability to forget about things like replication and sharding and the actual management of those things as they grow. That's a big deal. It may not seem like a big deal, but if you've made the jump from MySQL to NoSQL, or you're making the jump from point solutions to a very large and structured data platform, which is what's going on nowadays, that's huge. Horizontally scalable, I think we've beaten that one to death. And low latency. Unlike Hadoop and a lot of other systems where you effectively have batch processing by splitting it up over time and over space, React tends to deal with stuff in flight. And that's one of the requirements that I found was missing. Because you had to deal with things like memory management, process destruction, the fact of the matter was that the individual processes were very, very heavy for things like MySQL, PostgreSQL, Oracle, SQL Server, etc. Even in some of the NoSQL systems, it didn't meet the requirements of low latency, which is I get a piece of data, my system actively thinks about it, and it responds intelligently and gives me back what I need straight away, based on the information that's there. It doesn't need to go away to a Hadoop farm, wait a few hours, and then come back with a response. That stuff is for management. Day to day, you want your system to be active, you want it to be live, and you want it to be responsive. So low latency, while it's pretty low on the list, is definitely not the least important thing there. Any questions? Okay, cool. So if you have a database in the back end, and that's where all your data is going to live, structured, unstructured, etc. What do you plug into it? And this is actual data from Basho's research. As you might expect, the biggest thing that people want to actually do with their data is index it and find out what's actually in there. Oops, sorry, I ran out of stage. So you've got Solr up at the very top. The second thing they want to do is once they've done particular queries, they bring that stuff back and they want to push it out using Redis and basically serve out data structures based on their understanding of that data. So that comes up as well. We have Elasticsearch in there, which again does pretty much the same type of thing that Solr does, but maybe is a little bit more user-friendly, which is quite important. Spark is in there at about 9%. Now that seems very, very low, but there's something you should know about that. Spark is a very young project. I mean, it's about, 2 years old? Something like that. And for 9% of our mission-critical enterprise-class clients, 1 in 10 of them to actually start using it, and a lot of the rest of them to start raving about it, that indicates that it actually needs a bit of attention. We've got things like RabbitMQ and Kafka, etc., for other enterprise functionality. But typically, if you've got indexing, which thankfully something like React does, built out of the box, so we have Solr integrated into it, you really only need to focus on how you're going to cache out so that the rest of your enterprise platform, the services that you build, your SOA, your front end, etc., is able to call back and get that data immediately. And you may want to think about the analytics side. So that's why we're focusing on those parts. Okay? So, do you have any questions, by the way? Cool. Okay. So, Redis is wonderful. When I found it, it made my life a lot easier. Before it, I used to have to worry about things like Memcache And who here has used Memcache? Who here still likes Memcache? Wow, that was cold. Um, Redis is a key value cache. It stores stuff in memory. Doesn't just store simple, buckets and keys. It actually stores data structures. Now, it used to be you would have to write these down into a file or put them into a backend database. But if this stuff is live and is being used and manipulated, Redis provides a really excellent solution for that. It's not just a straightforward solution to have that data available and be able to manipulate it and present it. It also provides transaction support, which is quite important for audited data, etc. Provides automatic failover. So you have Redis clusters, which tend to grow and allow you to be able to provide these kind of real-time results out to very large systems very, very quickly. So the name of the game is actually very simple. If it doesn't scale, it will fail. And that's quite important. So Riak has a focus on scaling. Whatever technologies that we want, which talk to our database at an enterprise level, have to be able to scale as well. And Redis allows you to do that. Okay? Any questions? Cool. Go ahead.
If Riak is so scalable and so fast,
Mm-hmm.
why would you use Redis?
Because it sorry. Yep, so if Riak is so scalable and so fast, sorry, if Redis is so scalable and so fast, if Riak is, why do you need to use Redis, right? Very simple, because they do different things, okay? One is an actual repository of the data, which allows you to be able to do multiple things like multi-data center replication and scaling up and scaling out at an enterprise level. You can also serve many, many different types of requests at the same time. Redis is much more limited in functionality. Its primary focus is in dealing with rapid manipulation of data of certain types and actually allowing applications to consume them very quickly. So it used to be you had a very, very slow database at the back end, and then you had some sort of caching layer, CDN or something, and maybe some sort of in-memory Memcache key, etc. Redis replaces all of that with something that's actually enterprise class that allows you to scale that part of the functionality out properly. But it doesn't replace a proper database. It doesn't have, for example, replication across the different parts of the node. It doesn't automatically optimize. It doesn't read repair. It doesn't do any of that stuff at all. So for keeping your data safe and actually making it robust, available, et cetera, blah, 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 you want to rely on an actual database, not necessarily a caching layer like, for example, Redis. Does that make sense? Cool. Any other questions? Okay, cool. Next. Spark. Right, seeing as I'm the only one in the room who's actually heard of Spark, I could pretty much say anything now until you get access to Google. So who here has some experience with AI? AI, artificial intelligence. Like the Matrix kind of thing. Yeah. Okay, who here has done anything in the way of analytics with the data that they've got? All right. Can you give me, actually, that gentleman with the Hollister shirt, tell me what your experience was. Was it a positive one? Was it difficult? How did it go? Positive but hard. I would agree with that. Hands up, anyone who would agree that it's positive, but it's really hard to do analytics well. Yeah, that's about half the guys. Like I imagine the rest of you haven't really tried it. So, with analytics, you take a very large raw data set, you process it, you try and get some sort of value out of it so you can make a decision. And if you can't do those three things, it's not really analytics, it's something else. It used to be that everything was on file systems that weren't very scalable. Then people invented HDFS and they put Hadoop as a framework on top of that so they could chop things up and parcel them out. And then you would have very large data sets from servers, logs, etc., that Hadoop would then chomp through and then post back the results somewhere, and then the rest of your system would make them pretty and show them up. That actually is about 70% of what happens in the enterprise today. Spark is beginning to change all of that. What it's doing is allowing you to analyze data as it comes into your system in real time. You can take access of machine learning libraries that are now proven to be reliable, to be customizable for your particular use cases, and then you can pull data out, analyze them, and then push that data straight back in. So if you know what your problem is, if you know what you're looking for, it solves those things in real time. That makes it about 100 times faster than Hadoop. And in a competitive environment where you need to be much more agile and the data volumes are increasing and your decision space is decreasing, that's why people like it. And that's why I suggest you look it up. It allows you to be scalable up to 8,000 plus nodes. If you get to that number, please give me a call. I'm sure I could work out a support agreement with you, but most people won't. It's huge. So as you grow your Riak and Redis clusters, you can also grow your Spark clusters as well to cope with the analysis and to keep it at that cutting edge. You also have the ability to do streaming analytics, which plays very, very nicely with Redis as well. We talked about the machine learning library. And one of the key advantages that it gives you is even if you're dealing with data sets which are NoSQL based, which are unstructured, you have something like an SQL-based querying system you can put on top of your data sets to be able to pull data out and then represent it, which makes life very, very good for the vast majority of systems that are out there that have legacy code which is locked into SQL-based systems. Okay? How many of you have had to work on systems which aren't greenfield, that have been, inherited from somebody else? Yeah, so you know what I'm talking about. Okay. And you also have the ability to deal with not just flat bits of data, but also graph data, social data of the type that you get with social networks. Okay? Any questions? Cool. So this is a basic system overview of the kind of architecture that we're going to build. So now we're getting back into the boring stuff, so relaxation time is kind of over. The bits in blue are the actual client bits that you'll need to build yourself. The rest of it, Redis services, Spark services, Riak, etc., typically come out of the box. So after this, we'll go through the process of talking through where you get all the links in order to be able to build this. But you would typically start any enterprise platform by creating the database and then working out what your particular use case is, and that will allow you to pick the data that you need, and then you can decide whether or not you need to present it in real time, or you can leave it a little bit later, but Redis would come later on. Next after the database, and then after that, once you had a reliable system where you were able to analyze it and present results, no problem, then typically you'd want to decide what you did with the data that you consume, and that tends to be Spark. Try to think of Facebook, Amazon, Google, Apple, and their infrastructures as complex cellular organisms, okay, that process and feed off of data that's ambient in their environment, and that tend to, put that data back out after they've dealt with it. And so they will generate data for each other. They will feed off data from each other. And whatever you put into that space needs to obviously be able to talk the native language to be able to understand and consume that data. So all these different systems will speak REST, for example. They'll speak Google's protocol buffer stuff. They'll allow you to be able to process and translate from one data set into another. And so do you guys want to take a look at that for a second and ask me lots of difficult questions on it? I already see one in the back. Okay, so with Riak, you get a multi-data center replication as well for the enterprise version. You simply set up a cluster elsewhere, use the command line or something else to be able to connect the two clusters up, and you can do either full sync or real-time replication across. What that allows you to do is to increase your fault tolerance, your availability, and it also allows you to then separate out maybe your production taking in of traffic from the actual analytics of traffic. So one of the key trade-offs that we have to make, that's a really good question actually, is whether or not we want to slow down our production environment by doing the analytics there. It's like somebody who has to pat their tummy while rubbing their head at the same time. You know you can do both things very, very well, but generally you don't want to split up that concentration on actually processing the data. So what we suggest is you have, say, a production cluster, say about 5 nodes or something like that, and then if you can deal with everything in-house, you don't need to replicate out, etc., that's absolutely fine. But if you're going for something that's an enterprise that people are investing in, that want some surety about, have another cluster elsewhere for backup, and then maybe put analytics on top of that cluster, and maybe put a lot of the deeper processing, the AI stuff on the second cluster as well. Not only do you have the safety of having 2 different systems, one to fail over to, but you also have the ability to provide real live data back to the existing production system without impacting the performance. Does that answer the question? Yes, that's right. It would be bidirectional. Yeah. Okay, so Redis would pull its data out of the database that it's connected to, whichever cluster it's plugged into. So if it happens to be on the production side, it would pull that data out from there and present it straight away. The full sync or the real-time hot replication happens at a different level. So it happens between Riak and Riak. So you wouldn't need to necessarily replicate between Redis and Redis clusters, which I think is what you're aiming at, right? No. You just focus it on the cluster that you want, and you present out to the systems that want to consume it. No, it wouldn't, because Redis would rely upon Riak in order to get the information that it needs to present out. So let's say you have a cluster here, and you have another cluster here, and it's on the other side of the planet, right? This cluster syncs with this cluster, okay? But remember, it's this cluster that has Redis attached to it. And when those things are synced up, and they sync up typically in a matter of seconds, it's not a big deal, then Redis will just call out to its local cluster, pull the data back from that, and push it out. If there's an update to it, which there will be if your analytics is going on elsewhere and not impacting your production stuff, then when that happens, when that update occurs inside the existing cluster, then Redis will automatically pick it up and actually reflect that.
I guess the problem is that you can't really see what Redis is being used for. There's no plans for it.
No, that's right. You have to.
I've seen this was being used for ingress, but the way you just described that, that would work for ingress and that would be what it's like.
It works for both. So you have different use cases. You have ingress use cases and out, basically ingestion, projection, those kind of use cases as well. But whether or not you want to do it for that use case or the other use case or anything else, you still need to write proxies that are able to talk out to clients and that manage the actual relationship themselves. You still need clients that talk out to your front end or your back end, and you also still need to manage that yourself. But the key thing is that about 5-6 years ago, before Riak, before Redis, before Spark, that entire diagram would have been blue. You would have had to build it yourself. Or you would have had to try and take things which were maybe a little bit less good at the individual tasks, and you'd have to bolt them together. The idea of using enterprise class AI about 5 years ago in this kind of system and it being open source would have been unthinkable. Does that answer the question? Cool, okay. Next, let's get building. I hate to disappoint you, but this is going to be a lot of work. All right, so installing Riak takes approximately 5 minutes. This will be available to you guys afterwards, so please don't feverishly write any of this down. We have a 5-minute tutorial there, which allows you to pull down the actual database itself, build a development cluster. There's different options, etc. You can do that. We suggest having a 5-node cluster for production, but you can have a dev environment, a fairly simple one for about 3 nodes as well. And you can make those 3 nodes live quite comfortably on one laptop. You also want to install Reddit. So there's quick starts, downloads. These are all open source systems. So you can quite happily download them, work through them in your own time, install them in whatever environments you want, and then play them through. You install Riak, you install Redis, you install Spark. Then the hard work begins, because you have to build the client applications, you have to pick a use case in order to actually decide what your system will do, whether or not that be ingress or something else. And then you have to decide what level of control you want over your AI services or your Redis presentation or anything else. And those are what the connectors do. Sorry, let me just go back out. And you have the clients for connections. You can connect in initially to your data center or your database using a vast variety of different libraries. And they exist also for Redis and also for Spark. So the key thing about enterprise platforms now is that they're not usually just one piece of technology. About 4 or 5 years ago, I would say, yep, I'm a Java programmer. I've built Java enterprise services. That's what I do. A few years before that, if I was in a bank, I'd be saying, oh, of course, yes, I'm C hash all the way through, down to the core, you know? And then those are the systems that I've built. Now I see more and more systems where you use components of both, okay? I see more and more systems where you have Ruby on Rails, where you have microsites, where you have SOAs of different types, where you have, resiliency architecture, where you have different, even some systems have mesh, okay? So you will find that there's a lot of actual work to do with, say, taking a system which is fairly simple and clean and has a general purpose, base for building enterprise, and actually adapting it to the different interfaces that you currently have to deal with. A lot of this stuff you can build alongside your existing enterprise platforms. So you can have new database, have Redis there to publish results out. You can even take results from your existing systems, push it out. You can have Spark there, try it out, play around with the different use cases. Once you're happy with those, you can take existing data sets from your SQL systems or elsewhere, and you can start to process them in flight and actually test this out. And that's really what we try and do. Once you pick the use case, then you build your client for it. You operate upon the data. You maybe import some data, and you start to test out whether or not it publishes out using Redis, or it publishes out using, or it alters using Spark to make intelligent decisions, whether or not you can classify things or not, et cetera, et cetera. You pick an implementation use case. This is pretty much what we're talking about. There's a good one at that particular URL. There are others as well if you want to reach out to me afterwards, which I can send you out. And then you also need to create something akin to a SOA. Now, because Riak and Redis and Spark have their own native interfaces for talking to the outside world, those systems are quite comfortable in accepting REST API calls and calls of other types as well. So you effectively have a de facto SOA or 3 different SOAs out of the box using this system. You can put another layer on top of that to consolidate the services and to create an authentication, maybe a tokenized system, etc. And that will allow you to control access to this entire architecture that we had a look at. And finally, you need to add a presentation layer. Whether or not that's Ruby on Rails or Java-based or a C-hash front-end application which talks REST to the back end, or even something like PhoneGap if you want to do something for iPhone, etc. It really makes no difference. The presentation layer is a rendering of the data structures that you have at the back end. It's a presentation that allows you to deal with things that your typical users will have, use cases such as login, processing, display, decision-making, yada, 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 yada. That's kind of up to you. And finally, the most painful part, testing it, staging it, and releasing it. Okay? Do we have any questions? No? Okay, fair enough. All right. Testing, staging, and releasing. Hands up anyone who's surprised by that list. No, that's fine. Okay. You start deving locally. Typically use something like GitHub, or in the past it used to be CVS. Before that it used to be Source Cafe. Before that it used to be just writing stuff down on my arm. And then, you go into testing. So every time you anticipate a new piece of functionality, don't write the functionality. Don't try and design it. For the love of all that is good and holy, if you walk away from this remembering nothing, not even my face, remember this. Write your tests first, okay? Write the test for what it's supposed to do before you do anything else, because that will give you your final finishing line. If you're going through the process of coding, and I have seen this happen probably more times than I can even realistically think about counting, that line always moves, okay? Always moves, even if it's something small. As you're going through it, you will find ways to optimize it, and that optimization will move it backwards and forwards. And then, and this is the painful bit, this is a bit that you guys will probably all remember, someone will cut across you and go, we don't have time for this, we don't have resource for this, we can't do this in the way that you want, we have to do it the other way. And then you fail your original requirement. You're far better off writing out your tests and making sure that you have a set of regression tests that you can actually tick off and get done. The next thing you need is to test it in performance. There's no point in having something that does exactly what you want it to do if it takes 14 weeks to do it and you need it in 14 seconds. So you need at least 2 separate performance and regression testing environments. Finally, when you've done all this and you're completely sure that everything works solidly, everything is great, you take your designed fish and you actually put it in a fish tank to see if it swims, to see if it floats, to see if it does what it's supposed to do. Because your mechanical fish will have to deal with an environment. And that's where you find out with things like load testing, network partition tests, failures, outages, whether or not things like Riak or Redis or Spark actually do what they say on the tin. You can see whether or not it scales well, what the throughput is like, what the actual results are like as well. And finally, when you're very, very happy, you take your staging environment, make sure it's as close to production as possible, then you switch over. And then you wait for people to complain. But that's life. Here's a brief overview of it. I like lists, but I like diagrams better. Dev is where I've spent most of my life, to be fair. And that's why I write my tests before I even get down to deving, so that I'm pretty happy that when it gets to test functional, that whatever I write, be it Erlang, Java, C#, or even JavaScript, God help my soul. I used to do Visual Basic and COBOL as well, but that was a dark time. Once you've done the functional testing and you're happy with it, you test in performance. And typically you go backwards and forwards until you reach some threshold where your stakeholders will say, this is good enough for live. That should be done before you hit the staging environment. And with the staging environment, the key thing there is you just want to make sure that when you push it live, that you will get no surprises. Are there any network issues? Are there any issues with scaling the stuff up? What happens if one of your data centers goes down? What happens if your volume of traffic spikes overnight? Do you have things in place to deal with that? Et cetera, et cetera, et cetera. What happens if your security is compromised, et cetera, et cetera? So you build all of those things there, and that's very important. It gives you a chance to get it right and to show that it's right and get sign-off before you push it into production. And then, if you've done everything right, you've worked very hard, you've sweated blood and tears, eventually it'll get into production and you'll be happy. There are, of course, a few problems with this wonderful fairy tale. Number one, it's a lot to learn. There's a lot of actual hard effort involved in this. I talk about it like it's very easy. You could just, breeze off. It's just an afternoon, sit down there, work down through the list, it'll be fine. No, it takes time and effort and expertise. Most of you have that knowledge already at some level. But things like Spark that you're unfamiliar with, machine learning, etc., you have to actually go through and learn that. Plus, as most of you who've done any Erlang know, proper concurrency, proper scaling out, proper resiliency involves real discipline, and it's actually very hard. It is hard. There's no getting around it. You need to actually think carefully about it and be disciplined and be able to take that thought process and actually bring it back up to the meta level. How secure is it? That's something that we haven't even touched on. So Riak is excellent in terms of being able to talk out and talk back for security, secure channels in and out. Redis does the same thing, Spark does the same thing, but they're not specific security tools. So there's a whole security layer that you have to deal with. The reason I left that out of this particular presentation was because having worked with security people for most of my career, I've never managed to change their mind about anything. So in general, you get your security requirements from the business and from the security team that's working with you, and you try and work very well to make sure that they're happy and the business is happy. Like it or not, that's pretty much the environment that we work in. So the other bits of it become much more important to you, and then you make sure that the security is done. How do you scale? This is an excellent question that was asked earlier. If Riak is so good and great, why do you need Redis? Because they do different things and they do them well. Spark also scales in a slightly different way than Riak does, and Redis does. So part of the reason for the proxies that we talked about was to make sure that that scaling is managed, instances are managed well, and that that happens automatically. And finally, if you try and do this all by yourself, you have my sympathy. It's a lot of hard work. And having, some experience with yourselves about what it's like to actually code in the early hours of the morning, or have, something go wrong, or have people call you back, you need a team around you when you do this. And I strongly suggest that you do that, just for your own mental sanity, if nothing else. But it's very difficult to manage on its own. So the obvious question is, well, what do we do then? Well, we've got something in the works in Basho, and we can talk a little bit about that in terms of making it more easy to use and automation. So I'm going to just breeze through it fairly quickly. This is typically how we imagine that this stuff should look like, right? We've got service instances for Spark, Redis, Solr, Web, etc., up at the top. Your actual core services, things like replication, routing, cluster management, logging, etc., that should happen pretty much with all the blue bits and should be built in from the word go. You shouldn't have to think about that. It should just be taken care of. And then you should just build your use cases on top of something that works. Why do we have databases? Because we don't want to have to do the work of actually building a database, right? Why do we have Spark? Because we don't want to have to reinvent all the machine learning algorithms and stitch them together. And it's the same thing with Redis. Redis does something very well, but it overlaps with something else that does similar stuff very well. But why do you care? You only care if the use case is actually important to you. So it would be great if you were able to pull all of this together into one large system which could actually manage a lot of this complexity for you. And that's what we're working on at the moment within Basho, where you have things like storage instances like Riak, object storage, document storage, columnar, graph, all the different types. You just create the particular instance that you want, let whatever's underneath it, the enterprise platform, take care of the scaling, and then just, build your use case on top of it. And this is what it ends up looking like. We have the same core bits with Redis, Riak, Spark, but again, the blue bits are gone because they come out of the box with whatever platform that you have. Because those core bits are out of the box anyways, and because the core technology you need is to how to build it and how to scale it effectively and have a stable platform to put your enterprise use case upon, this is kind of what we're hoping for. Now you can build those systems yourself because it's completely open source. Or you can do what a lot of people do, which is sometimes use Amazon, sometimes use Dropbox, sometimes use what's actually there and deal with it, and push it out onto the cloud. This is kind of a platform as a service model. most of the people that you and I work with would never touch that with a barge full. What they would love is something where they can have control of their Redis, have control of their Spark clusters and the machine learning, have ownership of their data, maybe have that deployed internally on their own systems, and then all that other complexity happens the way it happens within the actual data platform itself. And yeah, I mean, there's a whole bunch of stuff in this presentation as well about the different sort of functionality of the data platform. We talked about what Riak can do and what Redis can do and what Spark can do together. But primarily, you're talking about core services of data replication, cluster management. You have the internal data store function, which every single enterprise in the world will need. You have, message routing. We looked at RabbitMQ and some of the other message queues, which may or may not be able to plug in and replace it. I mean, people like to integrate message queues. There's ZeroMQ. There's even standard queues from IBM, etc. Those things will all have their place, but it would be great if we could manage them all and actually tie up all the loose threads, right? And you have logging and analytics. Right now, you have to go and build your own logging analytics and tailor it to your enterprise platform. That's a lot of work. It'd be great if it could just happen straight out of the box. Again, this overlaps a lot with what was said beforehand. You have things like cluster management, so you can grow and decrease the size of your cluster automatically in relation to the actual volume of data and the variety of data that comes in. You have data movers, which intelligently loads data into Spark on the basis of which data sets are active at any particular time. Again, advanced functionality. And you've got writing back to, be it Riak or whatever other kind of internal store you have. It allows you to be able to take that data, play with it, and then push it directly back in without impacting any of the other workflows in the system. And that's typically how you'd want it to work. Again, performance scale, operational simplicity. I think I've labored that a fair bit. Redis, again, for high availability and incredibly fast caching. I may not have underscored this enough. I mean, half of you already know what Redis is, but the other half may not. Redis is awesome for not having to wait for the database to pick the data up. If the data is in flight and you're working with it and other parts of your system already need it, there's no reason to send it to the North Pole and back again, You want it available, you want your applications to use it, and when it reaches a checkpoint where it actually gets dropped back into your database again, that's what you want it for. And for a lot of the use cases, once the data is pulled out, you want to play around with it, and unless it changes, you don't really care, You only really care if you have to do it right back to it. So Redis makes those use cases much faster, much easier to deal with. With things like sharding, etc. in Redis, you want something that will handle that automatically out of the box. So one of the key differences between Riak and Redis again, with Redis you have to deal with things like sharding. With Riak, you don't. But you also don't get the advantages of Redis or the advantages of Riak across both systems. So you want a system that actually takes advantage of both and serves it to your use case. And you've got things like automated deployment. A lot of the reason for the entire system is so that if you have 8 or 9 nodes and you've got them split up, let's say over 2 clusters of Redis and then 2 clusters of Spark, and et cetera, that's micromanagement. That's what you do to make sure that what you've done is fine. That's like hitting the save button, right? That's great. But you want to actually play the game of winning money, of beating your competitors. You want all this stuff to be handled automatically because the magic is in actually making the right competitive decisions. Spark will help you do that. Redis will help you do that. Riak will help you do that. And the data platform that we're talking about will do a lot of that extra work for you that we talked about earlier. Okay, and the conclusion, because I'm sure you guys want to go off and do something fun now. It basically makes life a lot easier if you start from the bottom up and have a solid database. It's like stepping onto a stage which actually goes all the way to the wall. You don't have to worry if you make a misstep, quite important. It means that everything that you build up on top of it, you can be more and more sure of, and you don't have to worry about things failing. Counter side to that is you have to keep a track, because with Riak, you can lose anything up to like 60 to 70% of your actual cluster, and things will still operate normally. That's terrifying, because if you lose the rest of the cluster, you won't notice until maybe a little bit too late. So you need to set up monitoring, etc. Big data and big tech this is so obvious, I don't even want to complete it. I mean, it's here to stay. We live in a soup of information. That information is constantly being refined and targeted to who we are. And in many ways, a lot of the systems around us know us better than we know ourselves. And that can be quite scary. Building your own enterprise data platform, understanding what these challenges are, and at least having an idea of how people deal with them, gives you at least some notion of where the boundaries are in that new space and how you can fit into it. And you guys have the tools to actually be able to build these things. It's not hard now. It's a lot easier than it was 5 years ago. And 5 years from now, God willing, it'll be a lot easier again. And again, building a good enterprise architecture actually requires discipline. Building just an enterprise architecture requires going through that list I said earlier in one day and then running away. Finally, I want to reiterate that if your solution works, that's great for you. But if it's going to work for the world, it needs to be able to scale. And not just scale in terms of data, not just scale in terms of processing power, but also scale in terms of the nature of those processes, analytics, et cetera, and you need to be sure that it'll scale to match demand at every single point. And scaling up is almost as important as scaling down, because if you don't scale down quickly enough, you lose a lot of cash for no reason, and then the people that sign your paychecks come and get very angry at you. And our work at the moment in Basho has been, up until now, focused on making Riak the best product that it can be. And it's built on Erlang for very good reason, and we're very happy with that. But what we want to do is to try and take the complexity away from what you guys and what I've had to deal with for the entirety of our careers. We want to make these things easier for us to do so that we can get on with the real task of solving proper enterprise challenges and actually enjoying seeing the results unfold. Thank you very much.
Thank you, Jawad.
Do we have time for questions?
Yes, we're
Or?
stalling a bit of the coffee break, but if there are any quick questions, we can take them.
No. Sorry, go ahead.
You just mentioned that scaling down is important.
Yeah.
Your customers, how do they deal with scaling down the volume of data? I mean, they're collecting a data, filling up buckets.
It's huge.
Is there a pattern or strategy for dealing with when to get rid of data?
So you can add data. Most of the data that you add, you won't touch more than a few times. And then after that, it becomes relatively rare to be able to pull it back. So your core data set is actually your hot data set. Is typically bounded between 20 to 35% of your overall data set at a worst case. For particularly specific use cases, the more specific your use case, it can be between 5 to 7%. Okay? What that means is that you only really need to have between 5 to 7% of the information that you've pulled in available to you, either for processing or for publishing or for anything else. That means that when you get large volumes of data coming in, some of it you can actually archive straight away, which is the enterprise equivalent of throwing away, which means you never really throw anything away, right? And the data that you're actually dealing with, you can apply Spark and intelligent analysis to that to determine which bits actually give you the best return on investment. So you can actually focus on keeping those bits of data over a period of time, over a period of like 2 to 3 quarters, deciding what the best strategy is for keeping that data inside. And that's typically how you would do it properly. If I was selling you a product, I'd say, go here, download this, your problem is solved. But this is a real problem that you need to deal with intelligently, and that means having serious conversations with people. Does that help? Great. Next question. Okay.
think that coffee prevails.
I think so. I've been drinking coffee the whole time. Thank you guys very much, and I hope
Thank
you have
you,
a
Jawad.
lovely rest of the time. Thank you.
We have